All right, next couple of reactions. Let's look at another double displacement reaction. So we had silver nitrate. You place that in a test tube with calcium chloride, which calcium chloride is CaCl2 because calcium's a positive 2, chlorine's a negative. It takes 2 chlorine to match up. Okay, back to the chemical formula basics. All right, so I take a look at this and I can recognize that this is going to be a double displacement reaction. How do I know that? Silver's a positive, nitrate's a negative. Calcium, we said, was a positive 2 or 2 positive, and chlorine's a negative 1. So there's 2 cations and 2 anions, so it's a double displacement. 2 things are going to switch places. So on the product side, silver is going to go with chlorine. Do not look at this number. Just look at the charges. Silver's a positive 1, chlorine's a negative 1, so it's AgCl. Okay, this 2 was when it combined with calcium. That doesn't mean chlorine's a 2, that means just how it comes together with calcium. So just look at your charges. All right, plus, calcium's a positive 2, NO3. NO3 is a polyatomic, don't change anything about it. He's a negative 1. So if 2 are being given and 1's being taken, it takes 2 of the taker. So calcium, only needed 1 of them, and we have to put NO3 in parentheses to say we need 2 of those NO3s. Now let's balance. 1 Ag, 1 Ag. 1 NO3, 2 NO3s. So I'm going to put a 2 here. That coefficient 2 means there's also 2 Ags. Only 1 Ag. I put a 2. 2 chlorine, 2 chlorine, 1 calcium, 1 calcium. We're balanced. Double displacement reaction, which I'm just going to put as DD. Okay, let's say I put these 2 together and it gets cloudy. And actually this experiment, it doesn't get cloudy, it gets really chunky, it gets really gelled up. So you know a precipitate was formed, you know there's a solid. So think about what I just told you in the last video. Nitrates are going to stay in solution. So if this formed a precipitate, you saw cloudiness, you saw chunks, it's the non-nitrate substance, that guy formed my solid or my precipitate. Okay, so there's another example of a double displacement reaction where if the items produce a precipitate, if it's a nitrate, it's the other guy that produced it. If it's anything else, I'm not going to expect you to know that. This is a higher level skill to be able to identify the solid, so I'm not going to expect you to know anything more than that, just other than the nitrate. All right, let's talk about the setting hands on fire. We took methane gas, CH4, okay? We have plenty of oxygen in the room, which oxygen's a diatom, and we provided a little bit of heat, okay? Because if I just run the methane in the room with the oxygen, nothing bad's going to happen. Now I provide a source of heat, now we can get this to go through a reaction. All right, this is a typical hydrocarbon combustion reaction. Now we know that anything reacting with oxygen, okay, when oxygen's by himself, is called combustion. But if you have a carbon and hydrogen, hydrocarbon, that's going to produce hydrocarbon combustion. 2 products that we get out of this are CO2 and H2O, and we've talked about that several times in class. Okay, we balance 1 carbon, 1 carbon, 4 hydrogen, 2, so I'm going to change that and put a 2 there, so 2 times 2 is 4. 2 oxygen plus 2 is 4, I got to put a 2 over here. That's all it took to balance that. Not a tough balancer, but remember most of the time hydrocarbon combustions are bad balancers. So combustion is any time a substance is reacting with oxygen. So this would produce a combustion reaction. But this is also a synthesis reaction. And we get MgO. So this is an example of synthesis and combustion. Because it combusted, it reacted with oxygen to come together to synthesize. Up here was hydrocarbon combustion because you had a hydrocarbon and oxygen. Let's balance this guy really quickly because it's going to bother me if it's not balanced. 1 magnesium, 2 oxygen, put a 2 there, gives me 2 magnesium, 2 magnesium. Okay. The only other thing about hydrocarbon combustions I would say is it could be any hydrocarbon. So if I do the whoosh bottle where I put ethanol in the big blue bottle and I ignite it, you've got oxygen in the air. We've all seen it go up in flames. We've seen the whoosh. That's carbon dioxide and water produced. If I set my tables on fire, usually I'm going to use a type of alcohol like isopropyl alcohol or ethanol or something like that, usually isopropyl. When I light it, the The heat is provided. I got plenty of oxygen. I'm going to have the products of CO2 and water. Okay? So all hydrocarbon combustion reactions will produce carbon dioxide and water. All right, I'm going to do just a couple more double displacement reactions here, and then that's about it that you need to worry about for your labs. All right, I've got Na2SO4, sodium sulfate. You guys combine that with CaCl2. Once again, we can see that's a double displacement. Sodium's a positive 1, sulfate's a 2 negative, calcium's a positive 2, chlorine's a negative 1. Once again, from your periodic table, I mean, that's back from a while ago, so it's from your periodic table looking up charges. 2 cations, 2 anions, it's going to double displace. So double displacement here. Okay. All right, so sodium's going to go with chlorine. So positive 1, negative 1. NaCl. All right, calcium, positive 2. SO4 is a 2 negative. Good, they come together. CaSO4. All right, now we balance. 2 NAs, let's put a 2 there. 2 Cls, 2 Cls. 1 Ca, 1 Ca. 1 SO4, 1 SO4. We're done. This reaction does produce a cloudy appearance in the test tube. Okay, this would not be one that I would ask you, but just for your own knowledge, if it's an alkali metal and a halogen, it's going to stay in solution. So the substance that made it cloudy was calcium sulfate. That was the solid was produced. Not going to ask you that tomorrow, not advanced cyanide material, but just for your own knowledge, if this is going well and you take chem next year, then you can kind of keep that in the back of your head that, hey, if it's an alkali metal and a halogen, it's going to stay in solution. The precipitate was formed from this. Okay, I'm just telling you this produced a cloudy reaction. So double displacement reactions a lot of times are going to produce our precipitates. So that's what you want to look for. If you see a precipitate form, then chances are a double displacement reaction took place. Let's look at one that didn't do anything, and this is the last example I'm going to give you. Na2SO4 plus KiO3, which is potassium iodate. We put it together, nothing happens. No cloudiness, nothing at all. We just write NR, no reaction. That means both of these substances stayed in solution. Nobody reacted. It just stayed in solution. So you wouldn't call it double displacement. You just say it doesn't do anything. No reaction. Okay? Biggest thing for your labs tomorrow is when you're looking at your products, just try to identify what kind of reaction was it first. Was it synthesis? If so, are they coming together? Look at your charges. If it's breaking down, it's decomposition. If it's reacting with oxygen, it's combustion. Just look at what it can do for you. All right, that is it. Good luck.